self conductance are the conductances which are directly connected to the node. So by that what we can do is that whatever matrix formation that I have shown you, okay, so in that matrix formation we can just specify the things very clearly, so that the whole thing becomes a method, means the similar kind of rule we can apply for all the other circuits also, okay. So that is why we are just giving it a name,
Okay.
like G11, G12, G21, G22, okay, just a name we are giving for making it methodical, okay, or systematic.
Okay.
Okay. So let us go for the nodal analysis with dependent source in the circuit. Now, so for that I am just taking a circuit which consists of the dependent source. Okay, so this one is the circuit over here where you can see the dependent source. This is a dependent current source, okay, and this acha, can anyone say which kind of dependent source is this from the symbol and the representation here? Anyone?
Current dependent source.
Current, yes, that is current dependent current source, okay. Here the source that has been shown over here is current dependent current source, because the source is supplying 3I1 amount of current, and that current is dependent on the current which is flowing through some other branch, okay. So that is called current dependent current source. So now for this we will apply the nodal analysis for getting the node voltages. So by nodal analysis what we try to get? We try to get the node voltages. Okay, we try to find out the node voltages. Now for so what we'll do, we first recognize or we first label the node voltages, sorry, the nodes by their node voltages, okay. So according to the procedure. So can anyone say that what are the nodes over here? Nodes.
Three nodes.
How many nodes?
4.
Except this
Four and
reference,
one
except
reference
this
node.
reference, how many nodes are
Three.
there?
3, sir.
Three
Three,
nodes.
sir.
Three.
Okay,
Three,
so
sir.
so,
Yes, sir.
so I'm just
Three.
marking over here. You just tell me that whether these are the nodes or not. Okay, or if there is any extra node, if you think, then you please tell me. So this is a node over here, this yellow colored, okay. Now this is a node over here, and anything else?
No,
Yes, sir. One at a
No,
junction.
sir.
2 ohm and 3 ohm के बीच वाला सर.
Yes, sir.
Two.
2 ohm और 3 ohm के बीच का point.
2 ohm के
Sir,
3
2
ohm
ohm
के
and
वाला?
3
बीच
ohm
में
के
जो
बीच
point
का
है.
This
point.
one, this one you were saying, na?
Yes.
Means this one you were
Yes,
saying.
sir.
Yes.
But you see one thing, this point is connected directly with this reference.
Only will 2 will be there, so.
So therefore this is not a node, because already as I have mentioned this as reference, that means this node is also the reference node, because both of these nodes are at the same potential. Okay, understood? So how many nodes are
Yes,
there?
sir.
Only two.
Yes, sir.
This one and this one. These are the two nodes only. So what I will do, I will put level the nodes by their node voltages. Say, let us say this is suppose V1, this is suppose V2. Okay. Now now what I will do, I will go for the next step, that is we can apply KCL at the nodes. Okay. So KCL at node 1. Okay. So KCL at node 1, what it gives is that at node 1 if I apply KCL, that means this I am just writing it, you just try to match it, where if you do not understand then you please tell me. Okay. So at this node if I apply KCL, then this current through 1 ohm is V1 minus V2 by 1. Current through this 2 ohm, that will be V1 minus 0 divided by 2, and current from this current source. These are the three branches connected. So that is 15 ampere. Okay. So this is one equation. And then I will go for applying KCL at node this node 2. Okay. KCL at node 2, that is current flowing through this 1 ohm resistance is V2 minus V1 by 1, current through this 3 ohm resistance is V2 minus 0 by 3, V2 minus 0. What I am doing, I am just keeping the current going into in the left hand side, sorry, current going out, that is in the left hand side, and current going in on the right hand side of the equal sign. Okay. So V2 minus 0 by 3 ohm, current through the 3 ohm resistance is equal to current going into, that is 3I1. Okay. So I have completed means I have applied nodal and means KCL at all the nodes. So any confusion or any
सर
yes,
नोड 1 से आई करंट भी तो निकल रहा
नोड 1 से आई करंट ये वाला
करंट आई भी तो
हाँ वही नहीं अभी तुम बताओ कि ये दो इक्वेशन सही है ना?
सर फर्स्ट इक्वेशन में आई करंट भी तो निकल रहा है।
नहीं, मैं जो लिखा वो मतलब उसमें कोई गलती है क्या? देखो ये करंट मैं निकला के V1 माइनस वी2 बाई 1 ओम, ये करंट है। ये जो करंट है ये होगा V1 माइनस 0 बाई 2 ओम, ये भी सही है। ठीक है, ये करंट इक्वल टू 15 एम्पियर।
ओके सर,
सही है ना? इक्वेशन सही है ना अभी तक?
ओके
हाँ। अगर इक्वेशन सही है तो अभी देखो जो अभी तुम बोल रहे थे कि I1 करंट, हाँ उसका एक मैटर है इधर। ओके, सो दैट आई एम गोइंग टू से राइट नाउ। अभी देखो जैसे मीन्स वाट एवर method we have applied or whatever method we know for applying the nodal analysis, whatever steps we know, so according to the step I have applied KCL and KCL at all the nodes. Okay, but you see over here, after applying KCL to all the nodes, number of unknowns are how many? Number of unknowns right now there are 3 unknowns. 3. Which are the 3 unknowns? V1, V2 and I1. Okay,
I1.
so now using 2 equation you are not able, means you cannot be able to find out 3 unknowns, so you need another equation. So another equation, how will you get? You will get the equation by
V2
by
equals to 9i, sir.
yes,
V2 equals to 9i1.
V2 equal to 9i1. No, not 9i1. No, how it is coming 9i1?
No, sorry, sir. I made a
You
mistake.
can say that V1 equal to 2i1. Okay, because this is also reference node, na. So this one reference node, that means 0 volt. So V1 with respect to reference, the potential across the 2 ohm resistance is V1. Okay, so V1 equal to 2 into I1. So that is one relation that we can get. So that is the thing that I am now trying to write in terms of a statement, that is, you have to so here what is the additional unknown is this one. This is the additional unknown. And why this is coming? This is because of dependent source. Okay, so now so now what is the statement that we can give for that is that express any additional unknown in terms of appropriate node voltages. Okay, so express any additional, so this is the additional unknown over here, and express this additional unknown in terms of appropriate node voltages. And if I want to express this additional unknown by some appropriate node voltage, that means V1 by 2. Okay, so this is the third equation. So by solving, so therefore solving equation 1, 2 and 3, we node voltages can be calculated. So understood that what is the thing that is being introduced, or what is the extra thing that is there when there is dependent source present in the circuit. Okay,
Yes, sir.
please tell me any confusion. You just tell me that any confusion. It may be very simple, but still any confusion you tell me, I will try to explain that. Okay, so if it is done, then I will go for okay, so then I will go for a different thing. Okay, today is 5 minutes left, so I don't have the time to do that super node. So I will go for the super node in the next class, means tomorrow. But here just I am telling you one very interesting thing, that when so this one is understood, na. So once this is understood, then I will go for the for an interesting thing, that is okay, you just see that whenever there will be current sources present in the circuit, and whenever there will be voltage sources present in the circuit, then what are the differences that are they are making. Okay, so for that I am just drawing a circuit like okay. So let us see what it is. This simple circuit I have drawn earlier. Okay, so if this is the circuit, okay, let us see R1, R2, R3. This is I1, R2. So here in this circuit, if we apply nodal analysis, or if we try to find out what are the node voltages, so to find the node voltages, so we will apply that nodal analysis, suppose, and first we will mark all the nodes. So these are the nodes over here. Okay, so these are the nodes over here, and there you have to apply, say, V1, V2, V3, and this is V4. So how many equations you will be need, means you will need to get all the means all the unknown node voltages. So you need 4 equations. So KCL at all 4, suppose this is your reference node. All 4 non-reference node, reference node. Okay, so by applying KCL at all 4 non-reference node, we will get 4 equations. So then solve it. So you will get all the values. Okay, so this is the general way. Now suppose what I will do right now, I will replace the voltage source, means this current source, by a voltage source. Okay, so for that the same circuit, suppose this is V2. This is reference R1, R1. Okay, now you see again one thing. How many nodes are there? Again there are 4 nodes. So 4 non-reference nodes.
Yes, sir. 4 no.
4 non-reference nodes. So in this 4 non-reference node, you can see that I will put the name like V1. Okay, so sorry, this is your capital V. Okay, okay. Let me give some other name, E1. Okay, let us write it as E1. So the nodes are V1, V2, V3 and V4. Okay, now you see one thing. For this circuit, we will apply KCL at V1, V2, V3. Okay, and if we want to apply KCL at V4, it is not actually possible. Okay, means not possible, not possible is not the correct one. So V4, actually this is not needed. Okay, because why? Because the voltage source, this is the node of a voltage source with respect to reference node. Okay, so as we know, the reference, for the reference node the voltage is 0, so automatically the voltage V4 will be equal to E1. Okay, so this voltage will be known, so no need to apply KCL at this node, at this node 4. Okay, this is not necessary because this V4 node voltage is known. Okay, So therefore you can see that whenever there will be means we can write like that, a statement we can put, just we can put a statement over here, is presence of voltage source, present, this is important, presence of voltage source reduces one number of non-reference node at which KCL need to be applied. This is just an observation. So I think you can see over here, for the same kind of circuit you can see the same number of nodes are present, and but whenever there will be a single one voltage source is present, then it reduces the number of unknowns. Like here you see it reduces the number of unknowns by 1. Okay, so suppose there are 2 nodes, means two voltage sources present, means suppose if this is your voltage source, again suppose if this is the voltage source, okay, suppose E2 over here, then automatically this V1 will be also known. That means the number of equations or that should be applied for V2 and V3 only, okay, and no need to apply the KCL at this V1. So you see that one voltage source reduces one number of non-reference node at which KCL need to be applied. So this is just an observation, and this observation will be useful all the time. Okay, so many a times I think you will apply all these things, but you will not be means careful about that observation. Okay, so that is why I am just telling that thing right now. Okay, means not a big issue this one. Automatically whenever you will solve any circuit problem, you will automatically apply this observation. Okay,